So I'm really excited to be able to moderate our next panel. We have a really interesting group of individuals here working on some exciting new technologies, as we also have an operator perspective as well. And in this session, we're going to explore what is needed to go from the ideas and the sort of the potential of these technologies to actually mainstreaming them and helping them address aviation's climate issues. So on stage with me, we have Tom Grundy, who is CEO of Hybrid Air Vehicles. We have Val Miftakhov, who is CEO of ZeroAvia, JoeBen Bevirt, who is CEO of Joby Aviation, and Russ Dunn, who is the CTO of GKN Aerospace. And then also joining us remotely, we have David Morgan, who is Director of Flight Operations for EasyJet. So thank you all for being here. As I mentioned, we have a really diverse range of perspectives here today. David, I'd like to start with you as an operator. So you have all of these potential solutions available for decarbonization. You have SAF, you have battery electric, you have hydrogen. How do you view these different technologies playing a role in your roadmap to net zero?
Yeah, thanks. So I guess when we started to have a look at this, quite a while ago now, a few years ago, we quickly realized that we would have to think of energy quite differently than we have done for a long time. Indeed, as aviation has done for 100 years or so. And, as we move forward, the energy needed to provide for our transportation would need to be according to the application of that transportation. So I think that, our first thoughts were, well, what about battery electric? That's where all the cars seem to be heading in that direction and so on. But it became clear as we got into the detail that we would need to use something perhaps with a bit more energy density than that for the size and the application of the aircraft that we were talking about. But we did see an opportunity with hydrogen as being perhaps the most promising energy source for us as a short-haul airline, and perhaps being able to take advantage of that. So in developing our net zero roadmap, it's really a story of two halves. The first half of the period in this 2050 roadmap is around maximizing the efficiency of existing technology, more modern aircraft, improving airspace modernization, operational improvements, and of course, sustainable aviation fuel, which none of us can avoid in our journey here. But the second half, where we move to more radical technology, and in our case, as I say, we believe hydrogen is looking most promising. We're going to need a number of things to happen. We're going to need investment in technology and support with programs, and we've seen many of them with Project Fresson, Highfly, H2 Gear, Enable H2. There are countless programs, and they're all working hard to the same thing, to try and accelerate the technology to maturity so we can start commercializing it. We're going to need collaboration on a scale that we've never seen before, really. And, we find ourselves even in EasyJet talking to, offshore wind people, Ørsted and ITM Power, Air Liquide, people we would never normally associate with previously. But it's clear that collaboration is the only way we're actually going to be able to bring all of this to maturity. And then finally, we need a regulatory framework that supports this very bold leap into the unknown in many ways. Because what you can't have is a situation where an operator like EasyJet decides to make this bold move and is at a big competitive disadvantage to someone who has decided to just sit back and wait and see what happens. So we do need a regulatory framework which supports moving in this direction, and that's going to be a big focus of ours as well. So hopefully, David, that gives you a bit of a feel for our net zero journey and our thinking on that.
Thanks very much, David. I'd like to move on to some of the technology developers here. So JoeBen. Joby is a UAM company looking at sort of shorter distance, urban air mobility, transportation. How do you see that technology scaling upwards? How do you think sort of what you're doing now can help with our wider industry journey to net zero?
So when I began our journey on electric propulsion for myself in the early 90s, and then formally with founding Joby Aviation in the late 2000s, it was clear to me that electric propulsion could allow us to fundamentally transform the way we design aircraft. And that's been embodied in the ability to build aircraft that are relevant for people's day-to-day lives, making aircraft that can replace what are currently ground journeys in automobiles, trains. But we're now at a point where electric propulsion can be used for a larger swath of aviation, and specifically with using hydrogen as a fuel to run in fuel cells with hydrogen electric aircraft. This really fundamentally transforms the way we think about aircraft design. We're working with a fuel that is 3 times the specific energy. That is the amount of energy per unit of mass. When you're trying to make something that flies and you're trying to carry passengers, being able to materially increase the payload mass fraction by materially decreasing the fuel mass fraction is a really, really big deal. So having a lightweight fuel is a game changer for aviation design. The challenge with hydrogen is that it's 1/4 of the energy density, the amount of energy per unit of volume. And so we have to think about new airframe architectures, which where we get a lot of volume and which can take advantage of the tremendous capabilities that hydrogen has. So there was some questions in the last panel around which things we should be investing in as a civilization. From an aviation perspective, I'd like to be really clear and really crisp. For trips of hundreds of kilometers, battery electric is a good solution. For trips of thousands of kilometers, hydrogen electric is the solution. Burning fuels, including burning hydrogen at altitude, is something we cannot do moving forward. The effect of burning fuels at altitude is as large or larger than the effect of the carbon. And so we need to be very mindful as engineers about what we put our bandwidth into. We heard in the last session about that there were, we're hiring as many engineers as we can, and there's a shortage of really spectacular engineers in the world. We need to apply those engineers in a very judicious way on the solutions that are going to be transformative. And so it's really, really important that we focus, and that we focus on electric and hydrogen electric. And that is, in my view, it's important for us to be crisp. We need to invest our dollars there. I heard somebody say that we were going to need to spend $300 billion building a SAF pipeline. That's a SAF pipeline to nowhere, right? SAF is really important in the short term, but it can only serve as a bridge. There was also a question about timing. When do we need to deliver these solutions? We need to deliver them now. We need to start funding them aggressively now. We need to, the money we're talking about building SAF plants, we need to be putting those dollars into developing new aircraft such that we can deliver them by the end of the decade, not in 2035, not in 2040, not in 2050. We need to treat this as a really, really urgent issue, and we need to drive hard on it. Thank you.
Thanks, JoeBen. So I think we've heard from JoeBen that he thinks hydrogen is the answer. We've heard from David that he sees EasyJet's future lying at least partially with hydrogen. Val, ZeroAvia are building a hydrogen. You have invested in the future of hydrogen electric. How do you see this technology scaling up? Where are you currently? And sort of what do you think is needed to actually get it to commercialization and to play a significant part in this effort we're undertaking?
Yeah, thanks, Ed. Well, JoeBen did my pitch, so thanks, JoeBen. Appreciate that. But yeah, we basically agree, of course, that hydrogen, and specifically hydrogen electric, which is our approach, is key to commercial aviation going to this new future. We set up the company about 4.5 years ago, just in that understanding. And if anything, my previous background is all in the battery electric vehicles. Before ZeroAvia, I built and sold the company that built the largest smart grid charging network for electric vehicles, right? So we worked with all the automakers out there, or most of the major automakers. We had intimate knowledge of the battery development programs at all the automakers, and it's so firsthand what kind of problems you have. And while 4 or 5 years ago, everybody was running around and basically talking about, hey, in 5 years, we're going to have this magic battery. It's going to be 1,000 watt-hours per kilogram, and everybody's going to fly, and nobody will talk about hydrogen. We actually, or I saw that automakers actually tried hard. And you know, if you look at lithium batteries, tens of billions, and now probably over $100 billion total investments has been put into this, and the progress is slow. It's fundamental physics, right? Not only energy density or specific energy, but also the fundamental trade-off between that and the stability of the battery and the rechargeability and number of cycles, right? For a commercial aviation, for a regional aviation, you need to maximize both, right? You need a lot of specific energy or high specific energy, and you need a lot of cycles. A typical Tesla battery, I drive my third Tesla, right? So that car is a 300-mile car. And if you have 500 cycles on that car, that's 150,000 miles, right? So the lifetime of a vehicle, of a typical vehicle, is less than that in the United States, right? Less than 150,000 miles. So you're not going to have any problem. Now you go to the regional airline, and you have a vehicle that goes through 10 cycles a day, which is 50 times more intensive than a Tesla, and you run out of your battery capacity in 6 months. So JoeBen talked about the energy density or a specific energy. That's only part of the problem. The cycling bit is another problem. Then there's materials problem. So hydrogen, we think, is the only way to get the large aircraft, reasonably large aircraft that's relevant for commercial service, over the distances that matter, right? And then I agree with JoeBen as well that burning fuel over long term is not a great idea. Burning hydrogen in particular is not a great idea because you need, compared to fuel cells, you will need twice as much volume of hydrogen on your aircraft, and you're already hurting in volume, so you're going to need twice as much because of the lower efficiency. And you're going to produce at least twice as much of high temperature water vapor, that is a significant climate agent, at altitudes, because now you don't have carbon in your fuel, and typically, depending on the refinement level and all that, 40% of your energy in jet fuel comes from hydrogen, 60% comes from carbon. So you don't have 60%, so all your energy has to come from hydrogen now, and that means you have a lot more water output. So that creates additional problems. So really, if you look at fundamentals of this, hydrogen electric is the way to go. For us, as many of you know, we're already flying prototypes, and we're about to fly a 20-seat prototype out of our Cotswolds facility. Later this year, also, we'll fly a similar prototype in our California facility as well. End of the year, we'll demonstrate a 2-megawatt propulsion system that is targeted at 70-seat aircraft, for which we already have partnerships with de Havilland Canada. That's Flybe used to fly a lot of Q400s, so aircraft like that, turboprop side, and on a regional jet, Mitsubishi Heavy Industries CRJ. The timelines for those, 10 to 20 seat commuter, 3 years out, entry into service. Larger aircraft, let's say 70-seat aircraft, 50 to 70-seat aircraft, 5-6 years out, and the regional jet, hopefully 7-8 years out.
Thanks, Val. So it's interesting hearing that actually the timelines maybe aren't as far off as some people think, and maybe some of the earlier discussions today may be suggested. Tom, unlike I think the other technology providers on this panel who are looking to replace how we currently fly or the aircraft we currently fly on, hybrid air vehicles is taking a slightly different approach, and you're almost looking at a new market for aviation. How do you see that market developing? What are the use cases for your vehicles? And sort of how do you view the different propulsion options available there when you're thinking about this at a platform level?
Yeah, that's right. We do think about this a different way. With Airlander, we've designed something which you could really think of as the world's most efficient large aircraft, if you like. And it operates in a very different way to other aircraft that we see around us today. The reason we've done that is we see a very big gap between the current solutions that we have in fast, relatively expensive and carbon intensive aviation and the slower surface transport options we've got around us. So we've positioned this technology as an efficient solution within that gap. So when we think about our markets, we're thinking as much about the underserved markets around us, the 99% of freight that's moving around the world that is moving over land or over water rather than by air. Or we're thinking of the vast majority of people in the world who haven't set foot on an aeroplane yet. So there are big underserved markets there that Airlander is designed to address. The other thing that our product does is it reduces dependence on infrastructure. So we need less in the way of built environment around an Airlander operation. And again, that allows us to access those underserved markets with less infrastructure footprint and less of the damaging effects of that infrastructure going in. And then where I think there's real overlap with what the rest of the panel are thinking about and doing is that Airlander can, in some places, avoid the inefficient use of aircraft that we see around today, whether they're running on kerosene or whether they're in future running on hydrogen or other things. So a couple of examples. I mean, the obvious one to me is there's very little air freight that really needs to move at 500 miles an hour. So as well as those big markets that are outside of aerospace, there's big air cargo markets where we're flying things very fast that perhaps we don't need to. And even in passenger transport over short sectors, we know faster isn't always better. We know that high-speed rail can often outperform regional class aviation on very short sector routes. There's lots of those around the world where we're island hopping and doing other things. Today we're using regional jets, and with Airlander we can take a lot of the carbon out of that cycle just in operation. In terms of technology, fuels, power plants, there's some real similarities here, but we have a bit of a head start. So our prototype, full-scale prototype Airlander flying on kerosene, that delivered a 75% emissions reduction compared to alternatives. So we've got that efficiency built in before we move away from kerosene. Our pathway away from kerosene in service, we will go in with a hybrid electric configuration, and the electric part of that will be hydrogen fuel cell, so hydrogen electric engines. Those engines are on the test bench now with Collins Aerospace. So that means in service at 100 class regional aviation class 10-ton lift, that's a 90% emissions reduction against what we're doing today. And again, the timescales are close. We'll have that in service in 2026, and we'll drive for zero emissions over those sort of ranges with that sort of payload by the end of the decade.
So again, it sounds like this is not necessarily a far off. This is something that we could be seeing in a few years, which is really exciting. Russ, as a GKN, is obviously a supplier to both those in the incumbent industry, as well as I'm sure you're hoping some of these new industry players as well. What do you see the role of the wider industry in supporting these changes, and maybe broaden that as well to other stakeholders? What role do different groups have to play in sort of this challenge and in enabling alternative propulsion?
I mean, obviously we're a tier one, so we work with all of the big aircraft and engine companies around the world. I think we consider ourselves to be, at the higher end of the tier ones. You have certain suppliers who are very much in the sort of respond to customers' needs space, and others who work more in the anticipating customers' needs. We're very much in the latter. I believe personally in a really good supplier should operate one level above their station. You have to be able to understand the aircraft market, the customer, your customer's customer. You need to be able to translate that into what you think their requirements will be in order that you can start to trade for yourself, how you can best serve those needs. That's certainly what we look to do, whether it's on the engines, the airframe, or now with our biggest investment ever as a technology program. In our H2 Gear program, a £54 million program, shows that we're also committed to hydrogen electric as well. So I think first of all, the suppliers out there need to up their game. I think they need to operate, a level above their current capabilities. They need to push, whether that's through analysis, prediction, simulation, validation test, whatever. They need to push themselves beyond what is capable today in order to be able to offer better, materials, processes, products, solutions to their customers. Clearly, the recent announcements on growth on investment is important. I think all of us actively involved in creating a common voice for the narrative towards net zero as an industry, I think has been an important part to that. And beyond that, continued support from government, good collaboration, as David said. I mean, David and I have met several times. Fantastic collaboration from EasyJet, helping us to understand the end user's needs, at least through the EasyJet lens. I think that collaboration across the different stakeholders is a really important part of our journey over the next few years. The challenge, and I think this comes back to JoeBen's comment, is at the moment the lens is really wide. There are so many different elements to the roadmap. Whether it's in improving the efficiency of today's types of aircraft, use of SAF, use of hydrogen as a fuel cell through electrothermal reaction, or through combustion, or through electric. there are so many bits of so many ingredients there. If you then multiply those up by the number of different concepts and configurations that go across that, I think the technical resources out there, which I am a huge believer in, the talent and the possibility of engineering, focusing those on a smaller number of platforms that are absolute money winners that are going to drive the change in sustainable aviation in the future. I think I'm with you, JoeBen. I think we really have to start now to narrow the focus a little bit more and to drive the solutions that are going to enable that change.
Thanks very much, Russ. I think we've talked about some of the opportunities these technologies have, and I want to come back to the partnerships piece again shortly. But maybe thinking about some of the challenges. So, Val, one thing we heard earlier was sort of the infrastructure aspect of hydrogen is difficult, and there were some individuals who talked about, at least for long range, that makes it difficult to do hydrogen in the near term. How is ZeroAvia thinking about that, and sort of what do you think can be done to maybe accelerate progress on that infrastructure front?
Yeah, so we actually thought about it quite a bit right from the very beginning. Obviously, when we go to the airlines operators, and by now we have customers in the passenger domain and the cargo, and they all ask after. They say, hey, this is great, hydrogen, we believe it, power plants will work, the vehicles will fly, but where do we get fuel? How do we make sure that the fuel is available and the pricing of fuel is adequate? And so there, I think we have some good answers. From very early on, we partnered up initially with Shell as one of the top, or maybe the top aviation fuel supplier, and having a lot of relationships with the airports and the airlines, of course, and various operators. They're quite committed to hydrogen as one of the energy carriers for the future. And we're partnering with them on the infrastructure side. In the UK, we've announced a partnership with one of the large utilities, of course, one of the challengers here, Octopus Energy, which is really good. We've just announced in California a partnership with a relatively new company, ZEV Energy, or ZEV Station, that zero emission vehicle station that is looking to develop the infrastructure across initially West Coast and then the rest of the United States for all kinds of vehicles, hydrogen and electric, and including some of the airport infrastructure. Across all of this, the common theme for aviation is that we believe that aviation is actually the best use case for hydrogen. So we talked about, hydrogen is best type of fuel for aviation, but also aviation is the best type of use case for hydrogen because A, nothing else will work, right, as we've heard. And two, the level of concentration that you have for the demand is such that the infrastructure problem is much simpler conceptually. Like if you look at the light-duty vehicles, especially consumer vehicles, they have low utilization, low energy intensity. That's the worst place for hydrogen to start, right? And that's where the initial push occurred on the ground transportation, where you have to basically mimic the availability of the gasoline or petrol stations and diesel stations. It's just an impossible, well, possible, but trillions of dollars worth of investment. And you have to blanket the whole areas by these subscale systems. In aviation, let's take a United States example, 5,000 public airports, but 97% of all traffic, commercial traffic, is concentrated in just 3% of the airports. So you have 100 locations, give or take, that matter. And if you do the math, the concentration of demand is such that it makes total sense to have a very distributed way to produce the fuel, especially if you have multimodal production systems from green electrolysis, from some of the pyrolysis systems and such. So you can have the driving the economics of the fuel down to even below the break-even points with kerosene, especially given the efficiency premium that we have on the hydrogen electric or hydrogen fuel cells. So we think actually hydrogen infrastructure is a tractable problem in aviation and more tractable than in the ground transport.
Thanks, Val. David, I guess maybe building on my question to Val, as an operator, you sort of serve between that intersection between actually the technology that's being produced and the infrastructure. You're the ones that are going to be flying these, that are going to need access to that infrastructure. What is EasyJet doing in this space to try and help advance and solve some of these challenges?
Yeah, I mean, I would agree with what Val said there. You know, I guess some aerospace engineers would probably raise their eyebrows, but you know, making the airplane is really only half the problem potentially, and getting sufficient quantities of hydrogen at the airports is going to require a lot of work and effort. One of the things that we've done more recently is look at collaborations around an airport, and in the UK, in the southwest, we've already started a collaboration, and in fact, Val's team and Russ's team are already part of that collaboration in the southwest, centered on Bristol Airport. The collaboration involves not just aviation, but shipping, domestic heating, other users of hydrogen. And it's a question of how do we get things connected? How do we start using hydrogen? One of the projects that we're working on right now is hydrogen ground servicing equipment. How do we get some hydrogen into the airside environment of an airport so that we can start prodding the safety regulations around that, get people used to handling and using it, get skills for those necessary skills to be able to handle hydrogen and so on, long before an airplane arrives on the scene there. So I think hydrogen hubs are going to be an important part of the journey, and we're doing that not just in the UK, but in other parts of the network as well. I think just finishing up broadly on our ambitions on hydrogen, we welcomed the hydrogen strategy paper that was published by the government. But we think there will need to be more ambition there. When you look at the quantity that's proposed there, 5 gigawatts by 2030, I think fair to say that an airline the size of EasyJet would swallow up most of that fairly quickly. You look across the water at Netherlands, where they're looking at kind of 3 times that amount, and Germany something similar. So we do need to get more ambitious. From a government perspective on developing the source of hydrogen, because for sure there's plenty of applications that will be able to take advantage of it. Thanks, David.
Thanks, David. You talked about the need to be more ambitious when it comes to hydrogen, but I think rightfully so, the UK is really seen at the forefront of sustainable aviation efforts, and I think particularly when it comes to efforts around alternative propulsion. Russ, so what is your experience of working with the government here, and how do you think the policy environment they've helped establish has really helped the industry solve and tackle some of these problems?
Honestly, so we work in obviously UK, Sweden, Netherlands, US, through both local, national, and sort of European forums. Honestly, the mechanism in the UK is the easiest to work with out of all of them. I think. We have been very, very lucky to have created, through the AGP, through the ATI, a fantastic infrastructure that enables companies to, to step forward, to back themselves, to identify opportunities, and to, with an appropriate level of scrutiny, to make sure that those, the best ideas are supported and funding provided. we have been doing quite a lot of work recently in the Netherlands to sort of get to the same equivalent approach. And there are a number of other countries that are looking at the UK and wanting to learn how to do that. Sweden operates very differently. Obviously, clean aviation is the other significant forum. From my perspective, I think the ATI approach is fairer. It gives more opportunity for different parts of the aerospace industry, from sort of major primes all the way down to SMEs, the opportunity to collaborate more directly rather than through other sort of chosen primes and their concepts. Personally, I think the ATI method is better, and I think we should look to influence through clean aviation to also consider not just the benefit of the selected primes, but also the benefit of Europe offering better products to the rest of the world as well, which I think, and I think sometimes we don't always find that balance.
Thanks, Chris. And JoeBen, I saw you nodding onto that. Is there anything sort of your views on this? And I think I was with you last week and you were speaking about what California has done with electric vehicles. Do you think there are elements we can learn from that we can apply to aviation?
Yeah, I think that it is very valuable if we can get governments to follow the UK, the lead that the UK has provided. We can use the model that California did with zero emissions ground vehicles, but we really need to have governments leading and putting a stake in the ground, saying we really care about the overall climate impact of aviation, not just the CO2, but the overall climate impact. We need true zero aviation technology, and we need it as soon as possible. I come at this as somebody who has flown millions of miles in my life, and every time I get on a plane, I feel incredibly guilty because the climate impact of coming to be here, of every flight that I do is by far the worst thing I do to this planet, right? And yet I am an engineer, and I love to be able to meet with people in person. And so it's incumbent upon me as an engineer to provide solutions that will allow everyone around the world to be able to see the world, to connect with people in person, but to do it in a climate neutral way. So I guess to your question, governments need to lead on this. They need to put really clear mandates, and we as an aviation industry will follow that lead. And but it needs to be not just about carbon. It needs to be about the total climate impact, because the non-CO2 impacts are as large or larger than the CO2 impacts.
Thanks, JoeBen. Talking about solutions, so I think we've heard from all three of the technology providers here that actually solutions are not that far away. You're flying prototypes, you expect to have products available in the next few years. What is needed to go beyond that? So what do we need in the next 1 year, next 5 years to really begin to scale this so it can make more of a dent in aviation's overall emissions? Maybe we can start with you, Tom.
Yeah, I think there's a lot that's needed. There's a breadth and there's a depth here to make sure that we bridge these technologies from strong R&D into real commercial success and scale up quickly. I think, just echoing Russ's point, the ecosystem for R&D I think is very strong. It's very strong in this country, and it's quite strong I think globally. I think where we see things slow down is when we come towards the point of commercialization. We need to build the early adoption in the market, but then we also need early adoption in the world of finance. We need early adoption in the world of energy generation and infrastructure. All of these things need to come together at once in order to cross that bridge from development to production. And that bridge, that's typically, I don't think we're any different in aerospace from most other industries, that's a 10x in all sorts of different dimensions, moving from R&D into production. So I think at this point, that's where government does have a role to play. I think whether that's through commercial demonstrators, whether it's through setting out advanced demand signals, as we've seen, with vaccines through the pandemic, for example, where that really drove the engine of commercialization really quickly. Those policy mechanisms are really important, and I think they're sometimes overlooked when we look at the R&D channel. We then drop a little bit just as we get to commercialization, when a little nudge actually take these technologies into scale up much more quickly.
Thanks, Tom. Maybe Val, I can ask your thoughts on the same matter.
Yeah, of course. And our perspective is, of course, a little different because we're targeting the existing markets, right? So large commercial aircraft or medium and large commercial aircraft replacing engines. We're initially going after retrofit markets, so working with the same aircraft types. So for us, a lot of this new airframe angle or new market angle that both of you guys actually working on is a little less relevant. But within our scope, definitely, accelerated move towards larger aircraft requires increased R&D spending. And it was great to see ATI here getting more money, so that's great, and we'll see more momentum there. But we need more momentum, and we need to be more aggressive at funding R&D to get from the initial points that we all got to the larger and larger aircraft, longer and longer distance. So that's the first bit. The second bit on the regulatory side. There hasn't been yet a novel propulsion technology certified for commercial use. And there are some issues with resourcing at the regulators. There's some issues with the prioritization of things. So we need to really focus the regulatory agencies on these novel propulsion, novel aircraft types that help us move the industry to sustainability. And then, as JoeBen mentioned, once you get to the commercial availability, that's when we can get some blueprints from the automotive industry. And I was again in automotive industry, zero emission automotive industry before that. We got the blueprints, right? A lot of the blueprints. They need to be adjusted, of course, and adapted for aviation use case. But we know the fleet modernization incentives work, right? So, and especially probably with the operators like EasyJet, for example, that people have, let's say, billions and billions of dollars in midlife airframes invested, and we're asking them to turn over through them for the novel propulsion or new airframes. That will probably not happen very quickly unless we incentivize it. From the government standpoint, we incentivize the fleet modernization. And then we also have on the electric vehicles front, we have programs like in California, west coast of the United States, low carbon fuel standard credits, right? That incentivize the zero carbon or low carbon fuel production and utilization at the expense of the high carbon fuel production and utilization. And we can utilize those blueprints in an accelerated fashion in aviation, and that's what we should do.
Thanks, Val. Anything else on that matter, JoeBen? Sort of the next 1 year, 5 years, what are you looking for to really scale what you are doing in terms of urban air mobility and shorter distance journeys to those larger applications?
I think the industry just needs to decide that we're going to invest, ramp investment aggressively. Anything that whether it's demand signals or it's, so demand signals from industry, demand signals from government, governmental support, all of these things are a flywheel that builds. And so I'm confident we're going to get there. I just want to be more ambitious with our timelines. As we all recently heard, we are not on track with our climate goals. Our planet is in really serious trouble, and so we need to be more ambitious. It was just beyond inspiring for me to get to hear from Prince Charles and the leadership that he's shown over the past years on sustainability, and specifically on sustainability of aviation, moving aviation to climate neutral. That's just, it's absolutely incredible. He's saying let's do it by 2035. I would love to see us be able to achieve that. It's insanely ambitious, but as an industry, we owe it to our planet, and we owe it to the citizens of this planet to deliver. And we just need to focus, and we need to deliver.
Thanks, JoeBen. David, going back to you. So, as an operator, what are the considerations that you have when you are looking at the different technologies available, when you're looking at SAF versus hydrogen versus electric? We're obviously all interested in the wider sustainability picture, so the non-CO2 impacts, but from a purely operational perspective, how do you assess how these technologies can play a role in your business, and sort of what risks are there as you look to incorporate these into your fleet?
So I think, a starting point, you have got to lay out a decarbonisation roadmap. That roadmap must be aligned with science-based targets. You cannot just make up any old thing and say in 2050 we're going to have it all sorted out with an offsetting project on the other side of the world, something like that. So, for example, in EasyJet, offsetting is something we do as a complementary thing. It's not part of our decarbonisation roadmap. It is something that we can do right now, which gives some value, in different parts of the world and so on. But a decarbonisation roadmap needs to start now, and it needs to use all the levers that are available for decarbonisation through to 2050. People sometimes say to me, which one are you betting on? Well, actually, I'm betting on them all. I'm going to need them all and more. So I think that, as we move through the journey, some will mature quicker than others, and we'll be able to over-deliver on certain aspects of the tech, and maybe some will fall by the wayside along the way. In the very short term, we have got to reduce our emissions intensity targets, and we will do that with the quickest things we can do. More modern existing aircraft, the NEO aircraft that we fly nowadays is 15% more fuel efficient than its predecessor. Airspace modernization, we fly around in a pretty old system, frankly, of airspace. There's an immediate 10% or so that could be gained just by modernizing the airspace in the next few years. And SAF, of course, we're going to need that. We're going to need it at scale. Maybe, and maybe this is controversial, but maybe we need to even look at things like negative emissions technologies, where they are viable, direct air carbon capture and so on. So I think that nothing should be ruled out at this stage, but you must have a roadmap, and it must be science-based. You cannot just make this stuff up. And of course, at the same time, we are behind all of the innovation that's going to take us to where we eventually want to get to, which is zero emissions. And even as an airline, we have a kind of helicopter view of the whole ecosystem. We don't make aircraft or engines or anything else, but we do interact with all of those players, and we've got an important role to play in bringing that together. Thanks, David.
Thank you. So there's a question which has just come in from the audience, and that is, so did ATI's Fly Zero project get it wrong when it proposed hydrogen combustion for both narrow body and medium-sized aircraft? And I assume this may be referring to hydrogen combustion over maybe hydrogen electric. Val, sort of what are your... I think I know what you're going to say, but I'm sure the audience would be interested to hear nonetheless.
That's a good way to be on the spot for this one. I think what's happened there is the panel looked at the set of technologies that are available today, perhaps with maybe one incremental step that is pretty clear from today's state. And if you look at the state of the fuel cell technologies today that's in production, for example, in automotive, I mean, it's not great for aviation, right? And that's why the whole reason why a company like ZeroAvia exists, because there's a lot of technology development that needs to happen around various technological bits around the fuel cell to make it relevant, even for 20-seat aircraft and then beyond. So if you take those steps of increasing the energy density, increasing the power density of the fuel cells, you can get to the medium size for sure. And we think we have a way to get to narrow body as well over time. But if you only look at the current state and maybe the next incremental iteration, you would make that kind of statement, right? So the feedback would be, I guess, is to really understand the fundamental physics and the constraints of the technology. If you look at the fuel cell tech, there are no real fundamental constraints, or there are eventually, but they're not even close to what we have today in terms of both efficiency and the specific power and power density of the systems, right? To give a reference there, we today operate turbine engines at pressure ratios of 40 plus and pressures of far above 10, 15 bar in the chambers. And today's fuel cells in the cars operate at less than 2 bar and less than 100 degrees, right? So as you think about high temperature fuel cells, high pressure fuel cell stacks, you have so much way to go, right? In terms of the power density, in terms of specific power, and I think with projects like this, you need to really go along that route and understand the physical limitations or lack thereof.
Thanks. And within our Target True Zero project, that is something we are looking at. The Aviation Impact Accelerator has done some really interesting work looking at actually what are the potential of these technologies and how can they be applied. And we look forward to sharing that shortly. Sorry, JoeBen, you want to?
Yeah, I just wanted to add a little bit to what Val was saying. So as I look at the progression of batteries, when I first started looking at battery electric aircraft in 1993, I did research and saw that batteries have been improving for about 100 years at about 6% a year. That trend has continued over the past 30 years. One of the things that's inspiring to me about hydrogen electric and fuel cells today is that it's not just the specific power of fuel cells that are increasing at substantially faster rates than that, but the efficiency is also improving. And so what you see is the polarization curve is moving up and to the right, giving you better specific power and better efficiency. And so that's really, I think of the 6% as kind of the Moore's law of battery electric. And we need to develop the Moore's law and look at the rate of change of fuel cell specific power over time. And that will be the metric. We talked about how turbines have become 70% more fuel efficient over the last 30 to 50 years. We're going to see fuel cells go through that same transition. So fuel cell specific power is going to materially improve, and you can go in and you can look at the components of the fuel cell which have already been optimized for mass, and then see that you can optimize them again. So there's like multiple doublings of that you can get when you actually get down to the basic physics as Val was talking about.
And Russ, I see we have a minute and a half left, so yeah, very quickly, love to hear your thoughts on this.
So I was almost going to use exactly the same phrase as JoeBen. For me personally, I don't think we've even scratched the surface in terms of fuel cells. I think as we say, we've been working with batteries for many years. I think fuel cell power density has a lot more opportunity for growth, and we're the ones who are going to be driving that growth because we value the additional benefits, the incremental benefits of efficiency to a far greater level than probably the automotive market will. The impact to us of that greater efficiency reduces the amount of heat that you need to dissipate, reduces the complexity of the systems on the vehicle. The value to us is going to be much higher. So we're going to have to inspire and drive that improvement in efficiency. Just coming back to your earlier point and the ATI, I don't necessarily think the ATI got it wrong, but I think there is a natural consequence or sequence of environmentally beneficial solutions, and it starts at battery level. You should be pushing batteries to the highest possible amount, fully zero emission for everything you can possibly use it for. But there is a boundary. Beyond that, hydrogen electric propulsion is the next best environmental solution, and we need to be pushing that to the absolute boundary of what is possible. I don't yet know what the boundary of that is. We have some initial analysis. Actually, some of our recent analysis seems to be suggesting it might be even more efficient as we go larger. So we're still learning in that space. and absolutely we should be pushing that as far as we possibly can. Is there also a space for hydrogen combustion? I don't know, but we're not going to, we support both industries, and we're certainly not ready yet to place a bet in one and not to also invest in the other.
Okay. Thanks, Russ. I think we're at time now, but I think this has been a really interesting conversation. I'm sure we could have continued speaking for a lot longer, but I think if there are some takeaways for this for me is A, that these technologies are actually there from a technology perspective. These are not engineering problems, they're economics problems, they're sort of industry dynamics problems, but they are solvable. And that's something that we have to work together with as an industry, but also with policymakers, with other industries, to try and really unlock the potential that these technologies have. So I'd like to thank my panelists, and thank you all for listening today.